Caldeira. He is the gentleman who popularized the term ocean acidification. He is an atmosphere scientist at the Carnegie Institute of Sciences. Ken Caldeira, how are you?
Hi, Michael. Very good.
It's really nice to see you. And I think we started our discussion. You were out somewhere knee deep in the waters on some coral reef somewhere in the Pacific, was it?
Yeah, we just got back a couple of weeks ago from expedition to the southern end of the Great Barrier Reef, where we were looking at the effect of ocean acidification on coral reef growth.
Why would you be looking at ocean acidification?
Well, when we, plug something in the wall or drive a car, there's CO2 coming out of a smokestack or coming out of a tailpipe, and that goes into the atmosphere. And most of that carbon dioxide that goes into the atmosphere eventually gets absorbed by the oceans. And in the oceans, the CO2 reacts with seawater to form carbonic acid. And this acid can attack the shells and skeletons of many marine organisms. And so we were looking at the effect of this increased acidification on the growth of a coral reef.
So, let me just ask, is there too much carbon dioxide already in the oceans?
The current carbon dioxide concentration is higher than it's been for millions of years, but perhaps even more importantly for the ocean, it's rising extremely rapidly when viewed from a geologic point of view. If we were putting out the same amount of carbon dioxide over millions of years instead of over a few decades, it wouldn't be so important. But right now, where modern society emits carbon dioxide to the atmosphere about 100 times faster than all of the volcanoes and hydrothermal vents of the world. So we've more or less multiplied the natural rates of degassing from the Earth by a factor of 100. And a factor of 100 is just too much for the natural systems to take care of.
So, you say too much for the natural systems to handle. What does that mean? What impact does it, for example, have on the ocean food chain?
So ocean acidification, or the chemical consequence of carbon dioxide in the oceans, affects the food chain in a few different ways. The most obvious way is by affecting things that either make shells or skeletons out of calcium carbonate, and that includes most of the clams and oysters and sea urchins and corals and all these kind of things that we're familiar with. But it also includes lots of little tiny microscopic organisms that live in the surface ocean that form the base of the food chain. And it's likely that the species that make their shells or skeletons out of calcium carbonate will be severely negatively impacted. Some of them may go extinct. And there's a controversy among marine biologists whether marine ecosystems are like a house of cards, and if you pull out the bottom ones, does the rest of it collapse? Or are the ecosystems resilient, and if you remove a bunch of species, something else will take the niche and the upper, bigger fish that we like to eat and so on will survive. So it's a risk to the ecosystems. It's really unclear for the general marine ecosystem what it will mean, but which is one of the reasons why I study coral reefs, because there it's more obvious what it means, because you have one type of organism making the whole architecture of this ecosystem, and it's clear that if corals can't build their skeletons, the reef's going to disappear and that whole ecosystem will be gone. And we looked at two reefs so far. Each of them have been decreased their growth rate 30 or 40% over the last few decades. Right now, at nighttime, the reefs are dissolving. When it was observed in the 1970s, they weren't observing the reefs dissolving at night. And so these ecosystems, I think within a few decades, if we continue emitting carbon dioxide, will not be sustainable anymore.
Okay, so you said two reefs, two significant reefs. Right. In the evening, they're dissolving. In other words, they're dying, in effect. Is that correct?
Well, right now they're growing in the daytime and dissolving at night. As the ocean acidifies, the amount of time that it's dissolving will get more and more, and eventually will exceed the amount that it builds during the day, and then the reefs will start to dissolve.
So each coral reef is an ecosystem, and thousands maybe of different species develop, visit, flourish from those.
Yeah.
And so are you saying if the reefs keep dissolving, then we will lose a considerable number of marine species?
It's almost impossible to do experiments on full ecosystems. People can take individual organisms into the lab and expose them to acidified conditions and see what it means for an organism. To know what it means for an ecosystem is really tough because we just don't know how ecosystems will respond if you remove some things from the base of the ecosystem. So it's clearly a threat to ecosystems. That's coral reefs, if we continue our current emission patterns, I think will be a thing of the past. But what it will mean for the oysters in Tamales Bay or the mussels and sea urchins and so on that live around the California coast, it's less clear. But all of these organisms have been shown to be negatively impacted by ocean acidification. I did my PhD studying the effects in the ocean when the dinosaurs became extinct. And all of the great mass extinctions, or most of the great mass extinctions in Earth history, show the pattern of extinction consistent with ocean acidification being a major driving factor. And that means that organisms with shells of calcium carbonate tend to preferentially go extinct. Also organisms like sea urchins or clams, where the seawater is in contact with its body tissues, also preferentially go extinct. And the timescales to regenerate biodiversity after a mass extinction event typically is something like 10 million years. And so the kind of policy decisions we make over the next decades will affect biodiversity in the oceans for 10 million years or so. And obviously the things that evolve back won't be the same as what we lose. But we, at least for some ecosystems, we're likely to see great reductions in biodiversity.
Okay, so you said, among other things, and I found it very interesting, that in the past there have been mass extinctions, and just about every one, or maybe not the one where something came from outer space, the chemical composition of the oceans changed, and they became more acidified. And that is something that's happened with a lot of mass extinctions.
Yeah, even this one that wiped out the dinosaurs, it's thought that a asteroid hit the Yucatan Peninsula near Merida, but it hit into a platform with a lot of sulfur and CO2 in it, and the sulfur came off, and then there were acid rains, and so it looks like the surface ocean became acidified at this event. Okay. And again, almost everything that lived in the ocean that built a shell or skeleton out of calcium carbonate died off.
Okay, so we have something like that going on right now with the spread of ocean acidification. Now, I have a question. Is ocean acidification a subset of climate change?
They're both caused by the same thing, but they're different. That carbon dioxide causes the Earth to get hotter, and it causes the ocean to acidify. But the heating of the Earth is a property of the physics of carbon dioxide. Okay. Ocean acidification is a property of the chemistry.
So you focus on the ocean, and your job is to provide us with knowledge to help civilization make sure we are all sustainable and resilient. But when you go out anywhere, you turn on the television, read the New York Times, it's always, climate change, and it's not ocean acidification. How do you feel that so much attention is being given to something else that may not have a major significant impact on us to who knows when, maybe 2050 or even later? No.
I have a very pragmatic approach in that I don't, I care about what we do and not so much what we talk about. And so my view is that we need to stop using the sky as a waste dump for our greenhouse gas pollution, and we need to stop building things with smokestacks and tailpipes, and that if talking about climate change gets people to do that, or talking about ocean acidification gets people to do that, fine. But for my science, I'm eager to learn what it's doing to the corals and other ecosystems, but I don't care why we stop using the atmosphere as a waste dump.
Good. So I want to say I thoroughly enjoyed meeting you, and I greatly appreciate you've come on here. And we'll have to get together on television again sometime in the future, or in a film again.
All right.
But thank you very much, Ken.
Okay, thank you.
Hi, that was Ken Caldeira.